Hello and welcome to the Fun Physics, in which we discuss some NEET related physics problems and we try to learn them in a very easier way. And for the same series, I managed another video for you people in which we are going to discuss about the photoelectric effect. We will try to master this concept and some questions related to this concepts which have been frequently asked in NEET as well as in JEE examinations. So today I'll ask you a question like that will completely destroy the classical physics. Okay? So classical physics, it simply said that light की intensity बढ़ा दी. So what more electrons will come out. This was a belief of the classical physics. But what happened? I will ask you a question that लाइट की इंटेंसिटी बढ़ा दी, बढ़ा लो जितनी बढ़ानी है, फिर भी इलेक्ट्रॉन्स बाहर नहीं आए. क्यों नहीं आया? इसके पीछे जो रीजन है दिस वाई, वी नीड टू फाइंड दिस वाई. ठीक है, हमने इंटेंसिटी की लाइट की इंक्रीज. फॉर एग्जाम्पल एक मेटल का पीस है, यू आर लाइक throwing a light on it. Okay, a light is incident on this metal piece. You are like increasing the intensity of this light. फिर भी photo emission नहीं हो रहा है, sorry, electron emission नहीं हो रहा है इस metal से. Why? Now this is the question. But classical physics used to believe that, Newtonian physics, it used to believe that whenever you keep increasing the intensity of the light, more will be the emission of electrons from this metal surface. But यहाँ मैं तुम्हें बोल रहा हूँ कि electron का like emission नहीं होगा यहाँ पे. अब क्यों नहीं होगा? We need to find the answer of this why here. Okay. So most students like think like this. They think that more the intensity, more is the energy. Okay, and similarly more energy means more emission of electrons. This more energy, it means more emission of electrons. Okay, so this was the belief of what classical physics, or the belief of most of the students. This logic only works in the daily life, but atomic world they follow the different rules. उनकी एक अलग ही दुनिया है. So according to the classical wave theory, it's like it says that energy depends upon the intensity, not the frequency. So if we check the classical wave theory, it says that energy depends upon what? It depends upon intensity, not on the frequency. Okay, you know what the intensity is. Intensity simply means the number of the photoelectrons. Okay, this like classical wave theory, it believed that the energy of a light, it wholly and solely depends upon the intensity. Frequency नाम की कोई चीज ही नहीं है. So prediction, what was the prediction from this classical wave theory? Prediction was that the emission of electrons or the ejection of electrons, it will take place at any frequency. Like if there's a metallic piece, you are like just throwing a light of any frequency. Okay, of any frequency, say for frequency u, the emission of electrons will take place. This was a prediction from this classical wave theory. Okay, and increasing intensity like should always work. They believed that intensity is the like major thing that is responsible for the emission of these electrons from this metal piece. But frequency का कोई लेन देन ही नहीं था. बस लाइट के पास एक फ्रीक्वेंसी होनी चाहिए, फिर वो कितनी हो, कम हो, ज़्यादा, वो डिपेंड नहीं करेगा. बस फ्रीक्वेंसी होनी चाहिए, एमिशन विल टेक प्लेस एट एनी फ्रीक्वेंसी. बट किस पे डिपेंड किस पे फिर करेगा कि कौन कितने इलेक्ट्रॉन्स कब निकलेंगे? इट विल होली एंड सोली डिपेंड अपॉन द इंटेंसिटी ऑफ दिस लाइट. ओके, बट जब वेन एवर द एक्सपेरिमेंट्स टुक प्लेस, जब भी फिर जब बहुत बहुत सारे एक्सपेरिमेंट्स हुए, व्हाट एक्सपेरिमेंट शोड दैट लाइक एक्सपेरिमेंट शोड below a certain frequency no emission took place. Below a certain frequency no emission took place. So experiments, these were the observations which were showed by the experiments. That experiments showed that a particular frequency was there on which the emission of electrons took place. Okay, no matter how the light intense was, it doesn't depend upon the intensity. चाहे तुम लाइट वो लाइट की like intensity बढ़ाते गए घटाते गए, कुछ फर्क नहीं पड़ा इस emission पर. But हुआ क्या, एक certain frequency of the light, उसके नीचे emission बिल्कुल नहीं हो रहा है और उसके ऊपर continuously emission of electrons हो रहा है एक metal piece से. For example, उन्होंने क्या किया, एक monochromatic light है, उसको incident किया एक metal piece पर. So what they keep change, first they keep changing the intensity of this light, but emission was not taking place. But what then they did, they tried to change the frequency of this light. And particular एक frequency थी जहाँ पर emission of this electrons take place हो गया किससे, इस metal piece से. And after that, whenever they keep increasing the frequency above that point, okay, more emission of electrons took place. Fine. Okay, so this was the shock. Physics needed the new idea here. Okay, now then came the brilliant scientist. His name you must be knowing is, he was the Einstein. Okay, so now Einstein came. He told that light doesn't come continuously. Light comes in a packets. Okay, you must be knowing that he told that these light, they come in packets. ठीक है. So and he called them as photons. These packets of energy he called them as photons. Finally he told that जो light है, these are just like a packets, वो packets में ये travel करती है, and he called those packets as photons, and he told that these packets are nothing, just the energy. Okay, and he told that he calculated that the energy of a one photon, he told that this energy of a one photon, it is equal to, or it depends upon h mu. Okay, what this E represents the energy of photon, h you must be knowing that it's a Planck's constant, and u mu here it is frequency of light, or a photon. So Einstein changed the total scenario here. what the classical wave theory used to predict, Einstein reversed that. Classical physics, it believed that this energy of a photon, it depended upon what? The intensity of the light. But Einstein changed the whole scenario here based on his experimental studies. He told that this energy of a photon, it depends upon what? The frequency of a light. Okay. So intensity decides the number of photons only, but frequency decides the energy of photon. So this is the key line which you need to remember, which you need to grasp, that the intensity only decides the number of the photon. It has nothing to do with the energy of this photon. But what thing which like totally decides the energy of the photon? It's the frequency of this photon or the light. Okay. Now I told you that, and during the experiments, what happened? There was a certain limit below which all the frequencies of the light, they were unable to produce what? Emission of the electrons from this metal piece. Like I already discussed it with you, the experiment. In that experiment, I told you that a light was like thrown on a metal piece, and there they keep changing the frequency of a light. There was a particular frequency, okay, below which no emission took place, okay, and after that the emission of electrons took place. Okay? From that very experiment, a new concept arrived, a new word arrived, that was the threshold frequency. So now you need to like learn what the threshold frequency actually is. So basically this threshold frequency, this threshold frequency, it's basically the minimum, it's minimum energy which is required for emission of electrons from metal. Okay, like एक लाइट है, उसके पास मिनिमम फ्रीक्वेंसी कितनी होनी चाहिए दैट उसकी वजह से इस मेटल से एमिशन ऑफ इलेक्ट्रॉन्स या एस्केप ऑफ इलेक्ट्रॉन्स हो जाए. ठीक है, उसके बिलो अगर जो भी लाइट है उसका थ्रेशहोल्ड से कम फ्रीक्वेंसी है, नो एमिशन विल टेक प्लेस. हाँ, अगर थ्रेशहोल्ड की जितनी है इलेक्ट्रॉन्स विल एस्केप, चलो कम ही होगा, एक इलेक्ट्रॉन दो इलेक्ट्रॉन, बट एमिशन ऑफ इलेक्ट्रॉन विल टेक प्लेस. एंड इफ यू कीप इंक्रीजिंग द फ्रीक्वेंसी ऑफ अ लाइट above the threshold frequency, then what will happen? Simple, more electrons will like come out from this metal. Okay, so this what we say, this threshold frequency, we represent it by mu naught. It depends upon the nature of a metal. Okay, it depends the nature of the metal. You need to remember that on which things it depends, because what happens sometimes, the statement questions are asked in the NEET as well as the JEE. They like ask the question about this threshold frequency. Okay, this threshold frequency, like on which things it depends. You need to like remember it that it depends upon the nature of this metal. Okay, not on the intensity. Similar, it doesn't depend upon the intensity, but what it depends upon, it depends upon the nature of the metal. Okay, fine. This was the threshold frequency. Okay, now I already told you that this threshold frequency, it's equal to the mu naught. I represent it upon mu naught. Okay. Now I will tell you another thing, that's the work function, which we will represent it by phi. Okay. This phi, I will write it as work function, or the phi. It is equal to as h mu naught. Fine. So what is now the work function? Okay. What is the threshold frequency? Sorry, there's a minimum energy frequency here. And what is this now, this work function? Work function is similarly the energy, minimum energy, okay? Minimum energy required for emission of electron. So this phi, it will be the minimum energy which will be required for the emission of the electrons. Fine. Okay. So if this phi, h mu, if it is less than the phi, if the total energy, it's less than the work function, so what will happen? Electrons can't like escape. This is a simple concept, and this very easy concept. You can understand it better. It simply says that if the intensity of a light, there's any source of monochromatic light, okay, with some frequency, but what is happening if the energy of that light, say for example, it's a like source of a light, it's like incident on a metal piece. If this light carries the total energy which is less than the work function, what is the work function? Work function is like the amount of energy which is needed for the emission of electrons from this metal piece. But if this light is carrying energy which is already less than this work function, what will happen? No electron emission will take place. No electron emission will take place. So for the emission of an electron, to like the condition from by which the electron should like come out from this metal, what it needs, energy needs to be, the energy of that light, it needs to be equal, or it needs to be greater than what? This work function. Okay, this phi. This thing you need to remember for the emission of the electron. अगर एक लाइट को इस मेटल पीस से जिसका वर्क फंक्शन फाई है इससे इलेक्ट्रॉन्स को बाहर निकालना है, then this light should have energy. It should be either greater or it should be equal than that of the work function of this metal piece. Okay, fine. Now comes the heart of the modern physics. So heart of the modern physics, I will write that energy, that was like already told, it's equal to the h mu, where h is the Planck's constant and mu it's the energy, the frequency of this light over this photon. Fine. Now the part of the energy which was used to remove the electron, that will be the work function. This will be the phi. Okay, work function. So what now this work function means? It will be simply the part of this very energy which will be required for emission of electron. ठीक है, एक एनर्जी है ई, ठीक है, इसका एक पार्ट है, कोई लाइक हिस्सा जो जरूरत लगता है हमें एक मेटल से इलेक्ट्रॉन निकालने में, एंड वी रिप्रेजेंटेड दैट वेरी पार्ट एज 5। अब जो कुछ वहाँ पे बचेगा वो रहेगी स्टोर इन द फॉर्म ऑफ काइनेटिक एनर्जी। सिंपली मैं बोलूँगा, आई विल ट्राई टू मेक यू पीपल अंडरस्टैंड दैट एक मोनोक्रोमेटिक लाइट है, इट्स लाइक इंसिडेंट ऑन अ मेटल पीस। सो व्हाट्स हैपनिंग, सॉरी, हाँ, ए इस लाइट की एनर्जी ई है, एंड इस मेटल का वर्क, एंड इट हैज़ अ वर्क फंक्शन ऑफ 5, ठीक है। सो दिस ई इज ग्रेटर देन द 5, ई इज ग्रेटर देन द 5, फाइन। सो व्हाट्स हैपनिंग, ये एनर्जी इस पे पड़ रही है, ये इलेक्ट्रॉन को निकाल रहा है, अब 5 यूज हो रहा है ये इलेक्ट्रॉन निकालने में, अब इस ई से 5 यूज हो रहा है इलेक्ट्रॉन निकालने में। सो जो कुछ वहाँ पे बचेगा दैट इज ई माइनस 5, वो होगा बराबर काइनेटिक एनर्जी की, और वो रहेगा स्टोर इन द फॉर्म ऑफ काइनेटिक एनर्जी और काइनेटिक एनर्जी मैक्स, फाइन। सो काइनेटिक एनर्जी इट विल बी इक्वल टू, इस ई के बदले में लिख सकता हूँ एच म्यू, बिकॉज वी ऑलरेडी टुक लाइक ई इज इक्वल टू एच म्यू, वी नो दैट बाय मॉडर्न फिजिक्स दिस ई इज इक्वल टू एच म्यू, इट इज लाइक इक्वल टू एच म्यू माइनस 5। We also remember that this kinetic energy it will be equal to h mu minus h mu naught, because 5 was equal to this work function, it was equal to the Planck's constant into the threshold frequency. So this kinetic energy it will be equal to, h will be common, that's Planck's constant, it will be mu minus mu naught, fine. So this will be the photoelectric equation, okay, photoelectric equation, this is the photoelectric equation, fine. Now similarly NEET and like the JEE questions with some variations are asked, okay, like some cases are asked there. If V it's like less than the V naught, if the frequency of a light it's less than the frequency of threshold, what will happen? No emission will take place, no emission will take place, fine. Now case second, this was a case first, now case second, moving into the case second. When a light carries the frequency that is equal to the threshold frequency, what will happen? Electrons will nearly come out. Emission will take place, but a little emission will take place, fine. And case third, when a light it carries a frequency that's greater than the threshold frequency, what will happen? Electrons will come out, okay, electrons will come out, fine. So this is the thing, okay. Now I will tell you some gold MCQs. Yes, so what intensity, you must be knowing now, we already talked much more about this intensity, fine. Like if we increase the intensity, what will happen? Only number of electrons will increase, kinetic energy will remain same, because why? This kinetic energy it only depends upon the frequency, with this thing we learned, okay. And for the frequency, if you increase the frequency, if you increase it, what will increase? It will similarly increase the kinetic energy or energy, they too will increase, because why? Both the kinetic energy and energy they only depend upon the frequency of a light, fine. So if we now what we learn in this video, we'll just summarize this all. Summary of this video, it will be like photoelectric effect, what it like, it proves the particle nature of the light. Firstly, the photoelectric effect it proves particle nature of the light. And what we learned in this video, we also learned that the threshold frequency that was mu naught, okay, it's material dependent, not on intensity dependent, it is material dependent, not on the intensity dependent, okay. Also intensity controls the current, and frequency controls energy, frequency controls kinetic energy, fine. Also what we learned that below the threshold frequency, that's mu naught, no emission will take place, so these were some key concepts we learned in this video. So if you like now we will try to close this video, and if you remember like the photoelectric effect, modern like physics stop being the scary. So next video I think we'll make on the de Broglie's wavelength, like why fast particles behave like waves, fine. So thanks for watching this video, and if you liked it, just give a subscribe to this channel. Thank you so much.